Okay, so hello everyone. In this lecture, I want to discuss one question of your aircraft structure. Okay, and that question is previous year question of 2021, which was conducted by IIT Bombay, right? So this question they have given, okay, and unknowingly this question is from your indeterminate beam. Okay, so if you know the concept of indeterminate beam, you can easily solve this question. Okay, so again this question was asked for 2 marks, and this question was very simple. Although people feel that indeterminate beam question is difficult to solve, it takes time, it's lengthy, but it is not. If you know concepts of boundary condition, and if you know the formulas, some formulas of deflection, you can easily solve this kind of question in exam. Okay, so let's read the question, let's try out. Okay, so they are saying two cantilever beams AB and DC are in contact with each other at their free ends through a roller as shown in figure. So they are contacted through this roller. Okay, there is a roller support, there is a roller only. So both beam have a square cross section of 50 into 50, they have given mm, and elastic modulus they have given 70 GPa. Okay, if beam AB is subjected to a uniformly distributed load of 20 kilonewton per meter, then the compressive force experienced by the roller is. Okay, so why I'm saying it is a I hope you understand. First of all, the question what they are asking what is the roller support reaction, they are asking to find out in kilonewton. Okay, so I hope you can understand that this is the indeterminate beam, because here you will have a 3 unknown reaction. Again in this end you will have a 3 unknown reaction. Okay, this is RD vertical, this is RD horizontal, and this is a movement. Similarly RA vertical, RA horizontal, and there is a movement which is unknown to you. So there is total 6 unknown, and you have only 3 equilibrium equation, right? So you cannot solve this. So this is 3 degree of indeterminacy. Okay, so they have already asked how with the what determinant with the what number of indeterminacy it have the beam for 1 marks, they have already asked. So you should know how to calculate number of degree of indeterminacy. Okay, okay, so now you know this is indeterminate beam. Now we can not easily solve this using that simple 3 equations. Okay, so we need some more extra, okay, in this extra method. So what I will do, can you tell me, can you tell me is this is wrong or right? Okay, please tell me this, because at this support, at this roller end, deflection or for the beam to be equilibrium, deflection at this point should be equal. Deflection provided by this and deflection provided by this should be equal. Okay, so what I will do in this, directly what I will do, I will calculate deflection for this beam, I will calculate deflection for this beam. Okay, and at the end I will equate it to equate it the deflection, because deflection point C is 0, same, right? So deflection by beam AB should be equal to deflection by beam CD. So this is the equation I have to be system to be in equilibrium, right? So this is the condition. So what I will do, I will find deflection for this, and I will find deflection for this, and at the end I will equate it. So in the process I will get reaction at point C. Okay, so this is the thing we have. So I hope you know I hope you understand the concept. So what I will do now, I will use the principle method of, can you tell me what kind of method we will be using so that it will be easy? Method of superposition, the one of the best method for time saving to solve this kind of problem. Okay, so what I will do, I will break this beam, okay, in two half. So one beam will look like this. This is your A and B. Let me write here, yes, A and B, and having a UDL load, okay, of 20 kilonewton. So if I break this beam, it will be okay. Let me not provide the reaction first I will draw this. This is the roller, okay, and this is the second beam, second cantilever beam. Okay, now if I separate this beam and both the beam and try to separate with the rollers, what will happen? This when your beam bend in this way because of the UDL, it will provide compressive load to the roller, right? So according to Newton third law, there will be one reaction to the upward side. Okay, fine. Again, if this because of this 20 kilonewton, this will provide this kind of load to try to deflect in this way. So what will happen? Roller will experience compressive load. So this beam will provide a reaction in this direction. So right. So there will be one reaction. Okay. Okay. There will be one reaction in this way. A downward force it will provide. Okay, so similarly there will be one reaction also in a roller. So I hope now this beam is simple. I have divided this beam. Now what I will do, let me write first this becomes your R reaction, and again this roller will also take reaction. This is also same reaction, and this length is given as a 400 mm. Okay, UDL they have given 20 kilonewton per meter. Okay, now it is a very simple beam having UDL and cantilever, all this. So what I will write now, deflection for AB beam because of UDL having cantilever beam, deflection will be at the free end. What will be deflection? Can you tell me? It will be nothing but W L to the power 4. This will be L1, okay, divided by 8 EI. This is the formula. Okay, because of deflection I will get this kind of because of UDL I will get deflection in this direction. Okay, now because of this reaction at the end point I will get this kind of deflection, right? So I will take it as a negative, and R L cube divided by 3 EI. This is the one equation. Okay, now I will come to this beam, okay, which is again a cantilever beam. Deflection for CD will be again cantilever beam having a point load at the end, so it becomes RL, so it is cube divided by 3 EI, right? I hope it is yes. Okay, now I told you for the I'm reading that statement. To maintain the equilibrium, deflection at the roller will be same. Okay, so this is the condition, AB is equals to CD. So can you tell me, now I have already write down the deflection equation. So I will simply equate it at EI minus RL to cube divided by 3 AI. I will equate it, and it is nothing but this. Now what for the time saving purpose, I will tell you, don't substitute this EI, all this value in this. Don't calculate I for this, because what will happen now, if you take common EI from here, it will cancel out each other from both the side. It will cancel out each other, right? If you take common from this EI, and if you take common in this EI, both the thing cancel out from both the side, so need not to calculate that. We can save time, okay, in that way. So if you simplify, because this is L1 is given, you have to substitute L1 here, and L2 is a 250 mm. So be careful while substituting all those uh, parameter, because that they have asked a reaction in kilonewton, right? Length they have given in mm, and UDL they have given in uh, kilonewton per meter. So this is meter, this is mm. So if you convert mm into meter, or you convert meter into mm, so be careful while substituting all these values. Okay, so I have already calculated this. So if you simplify this equation, you will end up with getting R as a 2.4 kilonewton. So to maintain the equilibrium at point C, the roller will experience 2.4 kilonewton of compressive force. Okay, so I hope this is the why compressive, because if you see the free body diagram, they are experiencing, the free body diagram is looking like this. Okay, if you see the reaction is coming towards the roller, it is not going away from the roller, right? So this is the nothing but showing that roller is experiencing compressive load. So they have, as of now, they have already asked what is the compressive force. They have already said compressive, so we need not to substitute negative sign, we need not to do like this. If you do like this, it will be wrong and you will not get any marks. Okay, so they have already said compressive force, so you just need to substitute the magnitude, that's it. Okay, so I hope you understand the how to solve the indeterminate beam, how to use the deflection equation, and be careful while substituting the units also. Either you take all those things into Newton mm, or you take into kilonewton mm, or you take into kilonewton meter. Okay, so I hope this question will help you to understanding a indeterminate beam. If you have any doubt, you can ask me in comment section, I will try to answer there. Okay, thank you.